everybody, welcome to my channel. Today we will talk about R and S configurations, R and S isomers. Let's figure out what R is and what S is. So R actually is such an isomer of a molecule that rotates in the clock direction. S is the one that rotates in the counterclock direction, so to the left. Well, we know that molecules are not on the plane, they are in 3D space, in 3D dimensions, and they rotate, they have some rotation angle. So R and S show if its rotation angle is to the right or to the left. So how can we determine whether this molecule is R or S? Let's now figure out with examples. Let's take such a molecule with a carbon, we see, and it has some, say, radicals around it. Well, and let's take that such a molecule where hydrogen is behind. We see this dashed line. It shows that the bond is behind us. It goes in the opposite direction from the plane we see it. It goes in the opposite direction from us. So hydrogen is behind. Carbon is in the center. Now, what we do, we start the numeration. Look, we pay attention on their atomic masses. Among them all, we know that chlorine had the highest atomic mass. Well, the next one is fluorine, and the last one is carbon. Look. So chlorine has atomic mass, or let's say mass number. Not atomic mass, it will be more correct to say mass number. So chlorine has mass number bigger than fluorine, and fluorine has the mass number bigger than carbon, not CH3. We pay attention carbon on the first element. 3. Hydrogen is always 4. Hydrogen is always the last one, it's always 4. So now if we put the arrow in the direction from 1 to 4, we see that it goes in the counterclock direction. It goes from right to left. So it's a counterclock direction left. It means it will be S configuration. Okay. So as you see, that's actually not so difficult. This will be S, 1 chloro, 1 fluoroethane. So if we write the name, we always at the beginning have to write whether or not if it's S. So if it's S or RS, okay. So 1 chloro, we see it consists of 2 carbon atoms, so it will be ethane. On the first carbon we have chlorine and fluorine, so 1 chloro, 1 fluoroethane. Okay, let's now take another example. What if hydrogen attached to carbon is coming to the front from the flat that we see in the direction to us but not in the back to the back from us? Let's take this example. You can see the molecule on the screen. So I'm drawing, and now let's see hydrogen is coming to the front. Well, again we will enumerate them. The biggest one, according to the mass number, will be oxygen. See, we have carbons and oxygen. Oxygen will have bigger. Oxygen has mass number 16, while carbon has 12. So now, comparing these two carbons, we will take, okay, they both are carbons. Okay, in this case, we will pay attention on the full chain. And you will see that this radical, the first one, is bigger, so it will be enumerated as 2. The other carbon, with the smaller chain, will be 3. Hydrogen, as usually, will be 4. Let's now draw the line, the direction, and from 1, 2, in the direction to 4, we see that it will be counterclock direction to the left. But it seems to be S bar indeed. as you remember, hydrogen, we can see hydrogen is coming to the frontal part, front from us. That's why indeed we will have to flip our molecule. We will have to rotate it to make hydrogen go back, the back direction. Now you will see it. If we draw, we will flip the molecule like the mirror image. We will see that the direction of the arrow will change. Now it moves in the clock direction, so to the right, and it will be R isomer, R configuration. And let's name it. So let's find again the longest chain with carbons. We see we have 4 carbons in our chain. 1, 2, 3, 4. On the second carbon we have OH group. It means it will be, well, it will be alcohol. If 4 carbons, it will be butanol. It will be R2-butanol, because hydroxy group is on the second carbon. It will be R2-butanol. This. So actually it's not difficult. We can even draw it in this way, as you can see, to simplify. Well, let's now take another example. Well, let's take such a molecule where hydrogen will be neither in the frontal part nor in the behind part. It will be directly on the plane. So hydrogen will be on the plane. What can we do in this case? Here we will not use we will not use that method like before we did. Here we will use the circle method. Again, we do the numeration according to their mass numbers. 1 is chlorine, yes, 2 and 3 based on mass numbers. Hydrogen, as usual, is 4. What we do the next, look, we take the one who is behind. Look, chlorine 1, he is behind. You see, hydrogen is exactly on the plane, but chlorine is behind. So let's know what we will do. This number 1, we will put it into the circle and put it in the middle. So take 1, put it in the circle and in the middle, and then in the same order we will place the other numbers. So 2, we see it's above the 1, so we write 2 above it. 3 and 4, if we compare, 3 is on the left and 4 is on the right, so we draw them like 3 on the left and 4 on the right, and 1 is in the circle, as I said at the beginning. Well, we have to now rotate this. Rotate so that the number 4 comes to the top. Number 4 should be on the top. Number 4 will be on the top. It will replace the number 2. Number 2 will go below to the place of number 3, and number 3 will go to the place of 4. 1 will always stay on its place. So this is what we get. And after that, what now we have to do now, we have to place number 4 in the middle. We have to flip it. Okay, how do we flip it? Imagine that we have a human. I will draw, it's not a human, it's a molecule, just I draw in the form of human to make it clear. If we flip him, he will have upside down. His head will be down, his legs will be up. We do the same thing with this configuration, what we have just drawn. So in this case, if we flip it, 4 will go on the place of 1, 1 will go below, 2 and 3 will go upper. Look. So we flip it, and when we flip it, just 2 and 3 go up, 4 push south. Number one, and one goes below, it does not go up. One goes below. Okay, and let's draw what we get. And then you will draw the arrow showing the direction of 1 and 2, 3. With it goes to the right, or it's better to draw one arrow. Okay, so it goes to the right, so it's clock, it rotates in the clock direction. That will be our configuration. And let's write the name. We see that we have 1, 2, 3, 4, 5 carbon atoms. 1, 2, 3, 4, 5, and 6. It means it will be hexane. On the third carbon we also have chlorine radical, so it will be, let's draw it, 1, 2, 3, 4, 5, 6. 1, 2, 3. On the third one we draw chlorine, so it will be 3 chlorohexane, and we said it was R rotation, so R 3 chlorohexane. And let's now take another molecule. Take another molecule, as you can see in the picture. Well, again, we do the same thing. We just start first with our numeration. 1, 2, 3, 4 by their mass numbers. Bromine is the biggest one, it will be 1. Hydrogen is always 4. From these two carbons, the larger radical, it will be 2, and the other one will be 3. So we enumerate them again in the same principle. And we put, you see, number 1, so bromine is in the middle. Well, it's in the middle, so we put it in the circle. So it's not in the middle, I mean it's coming in the frontal part. It's not on the plane, but it's coming out of the plane in the direction to us, so we put it in the circle and in the middle. Then we write 4 is upper than 1, and if we compare 2 and 3, 2 will be on the right and 3 will be on the left. So we draw it like that. Now, if you remember what we did in the previous case, we were flipping, we were first rotating the structure to make 4 on the top, to put 4 on the top. Here we don't do it because 4 is already on the top. You see, we flipped it to put 4 on the top, but now we don't do it anymore because 4 is already on the top. Well, what we do, we start flipping it at upside, like, remember, upside down, fellows. We flip the molecule. Number 4 will replace 1, 2 and 3 will go upper, and let's draw what we get here. Let's see. So number 4 now comes to the center. Now let's draw the arrow of the direction. We will see it is moving from right to left, counterclock direction. Counterclock. So it seems to be S. However, if we pay attention, we see that, well, it's S, counterclock. Bromine was coming up to the frontal part. It was coming from the plane to our direction. It was not going backwards, so that's why we'll have to flip it. It's like we'll have to flip this configuration. Imagine that here we put a mirror and we see it in the mirror. It will be like this: 2, 3, and 1. So if we now draw this arrow of motion, we can see that its clock direction, it's moving to the right, so it will be R. And let's now draw it. We see that we have here 3 carbons. It will be propan, but it's alcohol because we see that there is hydroxy group. So on the second carbon we have bromine radical, and on the first carbon we have OH group. It will be like, look, we draw like 1, 2, 3. We have bromine on the second carbon, and on the first carbon we have hydroxy group. So it will be 2 bromo, 1 propanol. Let's write it 2 bromo, 1 propanol, and as we figured out, it was R configuration, so we're at R at the beginning. R, 2 bromo, 1 propanol. Now I draw another molecule in this one. Now you try to figure out whether it's R or S configuration. Just exercise by yourself, try by yourself. You can write your answer in the comments and I will answer you. Well, goodbye and see you in the next videos.